Bismillahirrahmanirrahim. Our today lecture is about flow irrigation, classifications of canals. We have already studied the canals and their design in detail. A canal is an artificial channel which generally trapezoidal in shape, constructed on the ground to carry water to the field, either from river or from reservoir and so on. There are two basic types of canal based on the nature of source of supply: permanent canal and inundation canal. A canal is said to be permanent when it is fed by permanent source of supply. I mean to say, when we have water supply throughout all the year, then we can say that is permanent canal. The canal is well made up, regular graded channel. In natural channel, like it has also permanent masonry works for regulation distribution of supplies. It has permanent small headworks to distribute water to further tributaries, minors and so on. While inundation canal usually draw their supplies from river when there is surplus water in the river, when there is a high stage in the river. So inundation canals are also known as flood canals. And they are not provided with any type of headwork for diversion of water. They are, however, provided with a canal head regulator only, and that canal head regulator is at some distance from the river to any open area. And canal based on financial output, these are productive canal and protective canal. Both these canals are used to get some financial outputs. Like productive canals are those which yield a net revenue to the nation, like we have main canals in our country after full development of irrigation in the project, and protective canal are sort of some short relief work constructed with idea of protecting a particular area from famine. And canals based on function of the canal: irrigation canal, carrier canal, feeder, navigation and power canal. Irrigation canal carries water to the agriculture field, and carrier canal also provides the same function, and also carries the water from one canal to another canal, from one river to another canal. That can also be called as link canal. Like Upper Chenab canal is example of this. And a feeder canal is constructed with the idea of feeding two or more canals. Example such canal is in India and Rajasthan feeder canal. And classification based on boundary surface of the canal. These are alluvial, non-alluvial and rigid boundary canals. An alluvial canal is one which is excavated in alluvial soil. Like in Punjab we have alluvial soil. This from where this soil came, from mountains due to sedimentation, due to erosion and sedimentation and sediment transport in the river. Those alluvial soils have been transported in this region, and we have alluvial soil here, such as silt. And non-alluvial canal is one which is excavated in non-alluvial soil, such as loam, clay or hard soil, like in rocks. And rigid boundary canals are those which have rigid sides and rigid base, rigid bed, such as lined canal, which we lined artificially. And canal based on discharge: main canal, branch, major distributary, minor distributary and water course. And main canal generally carries water directly from the river, from barrage or reservoir, and canals heavy supplies and is not used directly for irrigation to any of the water course in exceptional circumstances. And main canal act as carrier to feed the supplies to further branch canals. And from branch canals, these are the branches of the main canal in either direction, in both the direction, right bank and left bank. In general, branch canal also do not carry out any direct irrigation, but at some time we can offtake direct irrigation from those canals. And major distributary, that is also called as rajba. In local language it is also called as rajba, that take off from branch canal. And there are many major distributaries on one main canal, and there are many many branch canals on one main canal, and there are many further major distributaries on even one branch canal. And but the discharge is generally less as compared to the main branch canal. And further, they are real irrigation channel in the sense that they are supply water from irrigation to field through outlet. We can take outlet from major distributor and minor as well. So the discharge varies from 1/4 to even 5 cubic. And the minor distributors, these offtake from major distributor, and the discharge is less than 1/4 cubic. And from minor distributor we offtake the outlets, and then from outlet we have further water course, and from water course we have some mechanism like to divert the water into the field, like we have nakka, and we divert the water to the individual farmer field channels. Classification based on canal alignment, we already discussed contour canal, watershed and side slope channel in our previous lecture, but we will discuss here a little bit. So canal alignment can be done in these three ways. We have ridge canal. A ridge canal or watershed canal is aligned along a watershed and runs most of its length to a watershed. For example, if this we have to assign the main canal here, so that water can be offtaken from main canal in this direction and in this direction as well. Then we have to focus the river, and here we have barrage, and if we have to divert the canal from this point up to this point, then we should see the shortest possible distance and on the highest contour. So that is at a contour of 100, and it will divert water to downstream 98 contours, 96, 94. So this canal is here just. So that is main canal, ridge canal. So it can command areas on both sides of the bank. So you can see it can command the areas. We can often, like you can see, here is a distributor offtaken here, and distributor can also be offtaken at this place because slope is in this direction only. And here you can see we have some tributary here, and that is a tributary of the river that will join the river at this place. So we will have cross drainage work, CDW, that is cross drainage work here. The canal is just passing over the distributary. Here canal is just passing over the tributary. Tributary is below and canal is on upper side. And when the watershed takes a very sharp slope, the canal should be aligned straight here. If the slope is getting sharp, then canal should be straight. And so that the area of the loop between the watershed and the canal cannot be irrigated by this canal, and there will be higher on the ground side. So next is we have contour canal. So contour canal is just it can be understood by this word contour. So that channel align nearly parallel to the contours of the area, that is called contour canal. And then canal when takeoffs from a river in hilly area, it is not possible to align a canal on watershed. If it is not possible, then we can, if it is not possible to align on top of a hill, so the area which need irrigated are concentrated in the valley. The canal is then aligned roughly parallel to the contour, and contour chosen for the alignment should be so placed so to include all the culturable area of the valley on one side of the canal. So that is the main disadvantage of the contour canal, that we cannot irrigate the areas on one side, but we can irrigate areas on one side which are at lower slope as compared to the canal full supply level. So in mountainous area where it is not possible to align the canal on hill to irrigate both the side, then we have to just focus the valleys which need irrigation, where irrigation is possible. And third is the side slope canal. We already studied in our previous lectures. It is a channel aligned roughly at right angle to the contours of the country and is neither on the watershed nor in valley. Such a channel would be roughly parallel to the natural drainage of the country, and it does not intercept any cross drainage work. So from this figure we can see that if there is a hillway and we have to align a ridge canal here, then we have to take the water from river, and then we have to cross this canal over the tributary of the river. This is the tributary of the river, so that we have to make the cross drainage structures. And from this point up to this point, that is the main canal, and that is also a contour canal. And from this point to this point, that is main canal, and that is ridge canal. From this point, we have to make some cross drainage structures for contour canal and for ridge canal. This is the contour canal, and this is the ridge canal. So this is the example of contour canal from this point to this point, that only this side can be irrigated, but the upper areas which are lying on the contour higher than the 100. And this is the side slope canal, and this is the parallel system of our country, that is parallel to the slope of the country, and it is parallel to the natural drainage system of the country, which we studied here. So these are the general considerations for the alignment, that alignment of a canal should be such that to ensure most economical way of distribution of water, high command area can be irrigated, and minimum number of cross drainage works in order to save the money. And the alignment of a canal on a watershed being the most economical and is preferred for general rule. All the watershed lying in the command can be irrigated even on both the sides. The length of the main canal from point where it offtakes to the river to the point where it mounts on the watershed should be minimum. So this length should be minimum, this length. So you can say in mountainous, you can see here is written as heavy cutting. If there is mountainous area, there can be heavy cutting, and this cross drainage work can be costly. And this contour canal length should be minimum in order to join from this place to this place. We can also construct this canal from this point to this way in this direction, but its length will increase. So we have to see the shortest possible distance up to the ridge line, the main ridge line. The contour alignment should be changed this way or that way in order to reduce the number of cross drainage works. We have to align the canal with minimum cross drainage works, and the alignment should be avoid villages, roads and main roads, tracks. The alignment should pass through balanced depth of cutting. If not, it should involve minimum depth of cutting and minimum height of filling, because in canal we have depth of cutting, we have to cut and we have to fill if there are some depression. So we have to keep in view that the depth of filling should be equal to depth of cutting throughout the length, so that we should not get some soil from any other place, and we should not have to divert the cut soil from one place to other place. So the number of kings and small and the curves should be minimum. Small curves should be minimum, and the ideal length of the canal should be minimum, and branches should be economically planned. Alignment of a field channel or a water course in the farmer field, they should not be laid along the field boundaries. They should be capable of supplying sufficient water up to the tail end, because tail end farmers get very low amount of water. Separate field channel should be provided for high and low lands. The field channel should not pass through any rocky, brackish or cracked strata. Curves in the channel, curves should not be provided along the length of the canal except wherever it is necessary. It is impossible to avoid the curve we should develop. And when there is a curve in the channel, it disturbs the regime of the channel. And the concave side, which is outer side, is always under erosion, and the convex side, which is inner side, that is also subjected to sedimentation. So if this is the capacity of the canal, this should be the minimum radius of the curvature in order to avoid the erosion from concave side and siltation in the convex side. So that should be the radius of the curvature. Inundation canals, these are in particular area restored under the following situation: that when the flood in the river is of such duration that the water level in the canal remains high and fairly constant for quite a long time, then we should develop inundation canal. When there is an early flood in the river so that the kharif crops can be irrigated, and when the river has a late last flood at the end of the rainy season, so that the rabi crops can be irrigated. So these are the particular conditions where we can develop the inundation canal. In this book, our main focus is on inundation canal and design of a weir, if possible. When the area to be irrigated is in close proximity of the canal system, so that large area is not submerged in this case, and when soil has a sufficient stabilizing power, so that bed and banks can be stable under the adverse conditions. So inundation canal is similar to permanent canal. However, the major difference between them is that while in case of permanent canal, headwork weir barrage is provided, and that is off taken from those structure, and no such work is needed for an inundation canal, but instead, so this is important, an open cut in the river bank is provided at a higher level, so that whenever there is a flood, the water just overflow that bank. For the inundation canal to take off from the river, the bed level of the cut is kept much above the bed level of the river, so that only the flood water come outside at that there should be no water in case when there is no flood. So site selection is very important, and here we have the flood regulator, here we have high flood level, bed of inundation canal. So this is high flood level in the river. Whenever there is high flood level, the water should come here, and there should be flood regulator, and this flood regulator should be at some distance from the river bank. It should not be near to the river bank. So site selection is very important. Site selection for off-take point is very important, because the success of inundation canal mostly depends upon the site selection. So these are the factors. At the side of off-take, river course, river length should be straight. There should be no curve, and the banks should be stable, and the river should also flow with an average velocity and should have normal width. The variation in the water level should be low. There should be no extremely high level of flood like super flood in 2010. In case the offtake has to be located on a curve, it should be located on the outer side, on the concave side only, so that there should be no problem of siltation in the head reaches. If there is a silt in the head reaches, that in this inundation canal, that silt will also create some problems. The second condition is the offtake should be located as near as area to be irrigated. If a bypass of a river is available, then offtake should be located at the downstream end of the bypass, so that there may be less silt trouble in this case, since the velocity in the bypass will almost equal to that of required in the inundation canal. The velocity in the bypass channel will also equal to the velocity in the inundation canal. So whenever we have meandering process in the river will take shape of multiple channels and bypass channels. So we can offtake inundation canal from any of those bypass channel. The other advantages are also there. Let me show you. So this is a Indus river. We can see this is a river, and this river is divided into branches like this one. This is off-taking channel, this is off-taking. So we can take the inundation canal from any of these banks, like from here or from here, and the water in this channel will be in the flood season only, and all the river will be filled up in the flood season, and we can offtake the canal in those seasons. Design consideration for inundation canal. The trouble in inundation canal arises due to lack of control of water levels in the river, which cause deposits sand and formation of bore at the mouth with sudden fall in the river. So the design consideration are very important. A head regulator, generally known as flood regulator, may be provided a few miles down of the offtake point. If the flood regulator is provided at the offtake point, there is a danger of same being washed away during the flood. So that is the first precaution. An escape channel with an offtake at downstream of the flood regulator and should be there, and joined to the river may be provided to discharge the flood water back into the river. So there should be an escape channel which should take the water from that inundation canal back to the river. Vertical lift gates may be provided in the flood head regulator, which may be helpful in excluding the silt When there will be a vertical lift gate, when we will lift the gate, the deposited silt at the entry point will also get washed away. And full supply level of inundation canal should be keep equal to the fair irrigation level, which is irrigation level at the surrounding area. It is kept at a level at which water is steady in the river for 40 to 50 days during an inundation season, during the flood season, you can say. Next is canal bed level, that is kept as low as practicable to take advantage for higher depth of water for the period to store the water when the river is in low stages. Simply we can say the canal water carrying capacity should be more. Full supply discharge of canal is fixed based on the requirements, and then canal is designed. Bed slope may be fixed depending upon the slope available in the area, and the slope general is this. Bed width may be calculated thereafter, and we can calculate all the other sections. So advantages of the inundation canal: the cost of construction is very less since the silt and fine sand its way into the canal. The water carried by inundation system has a good mineral qualities, and since the water supply in the canal is intermittent, and hence water supply is not permanent, so irrigation in the particular is also intermittent, not permanent. Therefore, less trouble of waterlogging. Disadvantages are, as there is no headwork, the head of the canal is liable to be washed away. So flood water supply available from canal is not reliable. Duty achieved by inundation canal water is low. So duty is low. Less area can be irrigated with the high discharge. The cultivator lacks interest in his work due to unreliable supply of irrigation water. Inundation canal is not constantly under silt trouble. The size of the canal will have to be larger dimension to admit the full requirement of water within the limited time factor, because we have a limited time factor. In Pakistan, if we say we are getting higher amount of water in July, August and September, so this is the inundation period in Pakistan. The cross section of the canal is not well defined. The canal alignment is also not very precise. And maintenance of inundation canal system. There may be a lot of silting trouble in inundation canal, so maintenance is very necessary. Construction of subsidiary heads is so as to supply additional water when main head gets silted up. When the main head gets silted up, we have to supply some additional auxiliary heads in order to divert water and to wash away the silt. Construction of feeder canal, which links up a number of inundation canal taking off from the same river. So if there are 5 inundation canal which are off taking from the river, so those 5 canals should be interlinked with a feeder canal, so that the higher water can be diverted to the canal which have received low water from the river. And building a head regulator with an escape a few kilometers downstream of the takeoff will permit only required amount of water to get into the canal. In local language, there is also another system which is called as Bandhara irrigation system. That is a special type of irrigation scheme somewhere in between inundation and permanent type of irrigation cancer structure. In Bandhara irrigation, we have a weir type. It is from weir type band in the way of the river, and there are silt excluders here, and its depth is very less. For example, if it is of 2-3 meter, then the water within the 2-3 meter will be retained at the upstream side of the river, and the water which will be higher than 3 meter that will be flow over this crest and will flow to the downstream side. And here we have some under sluices, scouring sluices, and we have some gates here. When there is a silt problem here, we have to open these gates and silt will get washed away. And there is a head regulator also which divert water to the main canal. So that structure is little bit very less costly, even as compared to the permanent structure, a little bit costly as compared to inundation canal. So it is essentially a minor irrigation scheme wherein small stream which otherwise allow their flow to the to be wasted or damped at the place of Bandhara, small weir. So you can see the small weir. This is a small weir. This is not a weir as we studied in our barrage lecture. A series of such Bandhara dams are constructed, and the water available in the monsoon is thus made use of. And Bandhara irrigation scheme is very economical. The irrigation capacity of each Bandhara may vary from few hectares to only 400 or 500 hectares. So that is a weir. Here is under sluices. These are the scoring sluices here. Here is this crust. Crust is also at sloping. Where is that is reinforced concrete slab here, and this is downstream face, and this is upstream face. This is flow, and its height may be 2, 3, 4 meter, and this is river bed. Where should be the bandara can be located? The river should preferably be a perennial one. The river should be a perennial one, which should have flow throughout the year, so the water is available from river all throughout the year, and at the side good foundation should be available in order to construct this bandara irrigation system. And the site and the section at the site should be straight. Off-taking canal from such site should have good command area, cultivable command area, so available should be large and fertile. Natural banks on both the sides should be high, so that no land is submerged on the upstream side in the river. So these banks should be high, so that due to raise of water, no area should be inundated due to this structure. And the canal off-taking should not interfere with important drainage of the country. The cost of construction should be low. Working the bandaras are always constructed in series, so that water spilling over from the bandara is checked by the other bandara. So there is one weir, after that weir, after few kilometers, few miles, there is another bandara. So each bandara and canal system taking off from bandara form one complete unit. The canal unit take off from one side, and water in the canal is controlled by head regulator. The length of canal system should not be more than 8 km. The canal terminates in lower lying area commanded by the bandara. So that is the design of bandara, which we will use the equation of weirs. Bandara should be designed as low dam. It is usually trapezoidal in shape, with upstream face vertical and downstream face having a slope of 1:2 to 1:5, and 5 is vertical, 1 is horizontal. So that is the downstream face of the bandara, and we can see here this is 1:5, 5 vertical, 1 horizontal. This face is vertical. And crest width of bandara should be kept equal to h under root. Which is available height of the bandara, that is minimum of 1.2, maximum we can say 3-4 meter. Discharge flowing over bandara can be calculated from this weir equation. L is clear length of the weir, H is head of water over the weir, and 1.7 is coefficient. And section consider the broad crested weir. L is the length of the bandara, H is the height of the bandara. And scouring sluices 1 meter by 1.2 meter dimension should be provided at the bed, so as to exclude the silt from upstream to downstream site. The section of bandara shown in figure is checked. When there is flow in the river, there will be a flux on the upstream, and hence the section should be checked for differential head. When there is no flow in the river, there will be up to the crest level of bandara on upstream, and there will be no flow on the downstream. There will be flow on the downstream when we will open the gates of scouring sluices, under sluices.